Our next video will involve areas of similar figures or similar polygons. Let's say areas of uh, similar polygons. More particularly, we will be having triangles. Okay, let's have this. For example, we have a square of side A and another square. Of course, this is similar square. Let's say the side here is 2A and the side here is 2A. And if we want to get the area of the first square and the second square, we get here what? Area 1 will be A squared. Here, area 2 will be 2A times 2A will give me what? 4A squared. So that if I get the ratio of the two areas, A2 and A1, I will get here 4A squared over A squared will give me here a 4. Okay? So which means area 2 here will become 4 times the area of the first square. We can generalize this such that if we have here A here and we are going to expand our square k times, so this will be Ka, and if we take the areas, area 1 here will be A squared and area 2 will be K squared A squared. And again, if I get the ratio here, then I will get here K squared A squared over A squared, or this is the ratio of any two sides, the square of the ratio of any two sides, I mean. So if we have this, area 2 now will be K squared times A1. Okay, where did we get K squared here? That's actually the square of the ratio of any two sides. Let's say here, Ka and A, here Ka and A here will give me K squared. So we are trying to say here that the areas of similar polygons will have this relationship. You will just get two corresponding sides and then get the ratio and then square them. Okay? So similarly, if we have triangles, if we have areas of similar triangles, we have here, for example, uh, I'll just have this example here. Let's say this is 3, 4, 5 is a right triangle. I can expand that and uh, I will have here, if for example k equals 2, I will get here a 6, this is an 8, this is a 10. This is a right triangle, so the area here is 1/2 base times height, or this will give me what? 6. What about here? Area 2 here will be what? 1/2 base times height will give me a 24. If you will notice, if we get the ratio of the areas here, we get here what? 24 over 6, or this is 4. This indicates that the area of the um, triangle A2 is 4 times the area of the first triangle. Okay, that's giving you the example. But suppose um, we just have to have the corresponding sides. If I get any two corresponding sides, here, for example, 6 over 3, and then square this will give me 4. This is my k squared actually is equal to 4. So this is 4 times. We are now trying to say that the area of, if two triangles are similar, here, this is the theorem. If two triangles are similar, then the ratio of their areas is the square of the ratio of any two corresponding sides. Okay? Okay, which means area of the second triangle over area of the first triangle will give me a constant, which is squared. This k squared here will come from any two corresponding sides. So, for example, I have here A, B, C, similar to triangle, what? With sides A prime, B prime, C prime. And if this is my area 2, area 1, I can have area 2 over area 1 will be what? B prime over B and square that, or you can have A prime over A, etc. Okay? Or if you want area 1 ratio area 2, you have to come from this. You can say A is to A prime and then you square that. And squaring that, this will give you your ratio. Okay, this is actually your k squared. Okay, so we can apply this to solving uh, ratios, okay, of uh, triangles. Okay, let's see if we can apply that to what we have here. Okay, now number one, for example, what is the ratio of the areas of two similar triangles whose shortest sides are 5 centimeters and 6 centimeters respectively? Okay, so how do we get that? We have two similar triangles. So suppose the area of the first triangle is denoted by A1. This A1 here will be the area of the triangle with the side uh, 5 here. And then the area of the other triangle is denoted by A2. Okay, that one has this side, corresponding side. Okay, so the ratio of the two areas will be actually what? The ratio of the two corresponding sides, 5 is to 6. And then we square this. Or this gives us what? 25 over 36, which means I can say that A1 here is actually 25 over 36 times the area of the second triangle. Or I can solve A2. Uh, the area A2 here is actually what? 36 over 25 times the area of A1. In this case, 25 over 36 is a fraction less than 1, which means uh, the area of the first triangle is smaller than the area of this second triangle. In this second equation here, this area of the second triangle is greater than the area of the first triangle by this factor, 36 over 25. Okay? So, you can solve the other exercises by uh, just having that formula. Okay. Let's see. Let's have another example. Um, suppose the area of two similar, suppose you're asked to find the area of two similar uh, triangles are given to be 16 over 25. Okay, let's say the, the areas, the areas are the ones given now. So this is 16 over 25. So A1 over A2. Okay, the areas are uh, given to be in the ratio 16 over 25. And you're asked, what is the ratio of a pair of corresponding sides? Okay, so this one is actually equal to k squared, the constant of proportionality. Then, we can rewrite 16 over 25 as a square of a fraction. Since 16 is a perfect square, that will be a 4. And this is a 5. Okay? And then this will be my k squared. And your answer will be the ratio of the corresponding sides will be the k, which is 4 over 5. Okay? So that's it. You can answer these other problems here.